Okay, so we have played around a little bit with pandas, and now next step is plotting. So for plotting, this is another good feature of Python, and also this is what is recommended normally when you have some data and you want to generate some plot in order to include them in a paper or a conference poster or any other scientific publication, or well, could be also a blog article on a website. It's better if you create a script that in this case we will see how to do it in Python and generate this plot. Why? If the good thing of using Python or using any other, I don't know, you can use GNU plot, R, media. I mean, I'm talking about using a script rather than following like steps, for instance, in Excel or any other spreadsheet software that you need to follow the steps in a guide rather than in a script. Is that you can reproduce the steps easily. So imagine that you generate the plot and there is a change. You want to change the color, so you want to change. You just change one line in the script and you generate the same plot. If you do the plot using a software like Excel, you need to open the software and remember all the steps. You need to click here, now move here, change this size. So it's like more difficult to reproduce. Writing everything in a script is easier. Normally, when you share them with colleagues or you upload them to GitHub, for instance, is a much easier way to reproduce steps. Okay, having said so, we will now use matplotlib. That this is another Python library that we will learn to create the plots. And okay, so let's start. What we will do is we will first import the library. So we will do import matplotlib dot pyplot. So this is a library inside this library as a PLT. Let's execute it, and it should work. If it doesn't work, let me know, because it means that maybe the library is not installed. To install it, and we can create a simple plot. So let's, for instance, we will create a list. Okay, I see that there is a. What is the message that maybe that? What is the message that you get? I see that yeah, for some people doesn't work. That.
Juan?
Yes.
It might be. I mean, people should check with pip list or with conda list to see if matplotlib is actually installed. If you haven't done a, yeah, so module not found error looks like you've not done a pip install matplotlib. Oh, actually, no, in this case, I think matplotlib is misspelled in what Sachin, I hope I'm pronouncing your name.
Oh yeah,
is that correct? can't quite.
Oh no, yeah, exactly. It's a not. It's a mat, not math.
Matplotlib. Yeah. So if people can check just by running pip list, you could also try conda list, C-O-N-D-A space list.
Alejandra, yeah, Alejandra is also misspelled. It's like a matplotlib. There is an L that is missing there. Martina sees that this is like a warning, so we can have a look later, but shouldn't work out. Yeah, it happens with this like weird names that when you type them could be a typo. Cool. So please, if you have any other errors, let me know. And yeah, as Michael said, could be that it's not installed. What I can do. So you said if I type from the list, you get the list of modules that are, yes. So here should be matplot. Yeah, here it is. And before was an issue with the pandas. Yeah, so the module pandas is here. Yes, you can do it if you go to Anaconda Navigator and click, for instance, in PowerShell prompt or CMD prompt, and you execute that command. Okay, so now we have the library, and now let's start with our first plot. So just following the sample that is on the documentation, we can create two lists. That one could be time. So the list in square brackets could be 0, 1, 2, 3. So have 4 elements, and the position. This is another list where we include 0, 100, 200, 300. And to plot, show this in a plot, you can do TLT plot, and in brackets you specify the x-axis and the y-axis, the values. So you specify time and position. So if you execute that, you get something like this. So you get for the 0, 0, so it starts here. So for time 1, you get 100. So you get this plot. And for instance, if you modify instead of 300, you type 500, you will see that it changed. So well, this is the most simple way of creating a plot. That if you see that by default create a line, well, 2D, this is the type. That is a comment because, okay, we are using a notebook, we are using Jupyter Lab, but in case that you use a Python script, please don't forget to use a plt.show. If you use that, a new window will appear. Actually, I will execute that and see. Well, okay, because yeah, that's when I do plt.show, includes the window here. But when you are using a Python script, a new window will appear on your desktop, and you will see that plot. Okay, things that you can change. You can add labels, so you can say tlt.x label could be time in hours. Here t.y label could be position in kilometers. So you execute this, and you see that now you have the title and the position. Sorry, the title, the label on the x-axis and in the y-axis. I think it's possible to add the title inverse. Okay. Let me try. I don't remember. Okay, so you have the title on top and position and time. There are many. You can do many things with the to customize this, like changing colors, changing font, changing size. We will not see all of them today, but there are many resources where you can find all of this documentation to customize these graphs, these plots. So, well, here you have the first one, and also you can. This is using we're using matplotlib, but another feature that pandas include is that we can also plot from pandas. So how we can do that? What I will do is I will okay, what I will copy the script in the shared document that is here. Doesn't look quite right. Give me a second. Okay, this looks better. I don't know why when I copy something here, it totally modifies the. Sorry, one moment. This should be okay. Hopefully. Okay, so this is the. I will. Okay, so this is the script that I will execute. That is here. I will share again the link in case that is missing. So copy. Okay, so let's explain what I'm doing here. Well, we don't need to do this because we have already imported pandas, but just for the sake of completeness, you need to import the library. And in data, we read, in this case, again, we read Oceania, and the column, the index column is a country. With this function, what we do, because you may remember that the column names is GDP per capita underscore. So what we can do is we can extract that year and get rid of the rest. So you can use the with Python you can use data and column. Okay, I will add here a new well, okay, let's execute. There's another way is I can comment that. Okay, so I import pandas again and read this CSV file. So if we go step by step, we can do data columns, and we see that I get this. But also an operation that I can do is I can convert them to a string. But I can apply a string the method. The string method is strict, so takes this and gets rid of the. So if I execute this, you see that now the index is 1952, 57, 62. So I have the years rather than the whole thing. So I save that in years. So the next step is I change the type to integer, and then I, for instance, for the I will print the only Australia. So I do data.location Australia. If you remember, here we use square brackets to select the row, and then dot plot. So if I execute everything at once, we see that we have a new plot where we get the GDP per from 1950 to 2000, well, more than 2000, and we get this. Also, we can change here if we can again we can add more. We can edit the plot. We can do, for instance, add TLT.title. TLT.show. And you can do modifications. So here is like you create the plot, and later you can these lines, the following lines, you can you can edit the title, y-axis, the x-axis. So we can do plt.x-axis will be the year, plt.y-axis. Oh no, sorry, it's a white label. Oh, my bad. Here, white label could be like dollars, and you can get something like.
Juan, there's a question in the chat. Have you seen it? About the year. It's the data type.
Ah, yes, thanks.
Is that because you've basically you've stripped that GDP per cap prefix, and really years is now a string, so that needs to be converted into an integer?
Yeah, exactly. Yeah, that also we can, if we do type years, this will tell us we need to use again print, but I forget. Oh, well, okay, it's an index, but yeah, it seems that because we need to remove this, the type is integer. Sorry, is string rather than integer. So that's why we need to modify and create integer. I mean, if you print years, you see here data type is object, so doesn't say too much about the. I think that's why you need to modify. Okay, so we have a. Okay, let's make this. Also, rather than one country, well, I can say in so I can get this. So rather than one country, we can print the two countries. So a way to do that is we have a data, have the transpose, and we can do a plot. Oops. So if we do that, we see also the legend at the top left, and we see that Australia in blue and New Zealand in orange. Also, we can, and again, we can change TLT.title, GDP per capita. So, oops, see that there. Okay, see that there is in the chat that there is an error. Okay, I think you are having this because if you execute everything again from scratch, it will work. But the problem is here that in data, if you see we get the data columns, we convert to a string, we do the strip, and we save it in years. But later we rewrite data columns. So when we rewrite them, maybe that's why you are getting this error. But yeah, not sure. We can have a look at it later. Okay, here what I'm plotting lines, but we can do, there are other options. Imagine that I want to print bars rather than lines. I can choose the kind of the plot that I get. So in the previous example, that is this one, if I say kind equal bar, I repeat again, you see that rather than a line, I get another chart with the bars, and I get the GDP for Australia and New Zealand, and rather than using a line, use bars. For those that you have used R, and you like the style that ggplot uses, you can also change the style. How you can do that? You can do tlt.style.use ggplot. And you see that the style now has changed. Should be now is similar to a ggplot. And this is just like a very small, let's say, subset of options. So what we are seeing it right now. There are many other options that you can use to for instance, we can also another if you don't want to use a plot from the data frame, also you can extract the data and plot it because you may remember that for this graph we have two vectors or two lists, and we print them. So you can do a similar way. You can do a similar way with the data frame. So you get the years. Okay, see that there is some.
Yeah, it's me, Juan. Yeah, there are a couple of questions in the chat. One from Pablo, and I guess the answer to this is yes, that the T-plot is possible because we're reading data using pandas. Or,
yes.
Or actually, we're plotting the data. And
yes. Yeah, the second question is, can you explain how to save the plots as PNG and EPS? So actually, yes, let's do that. And regarding the first question, that is this plot possible because the data was using pandas? Yes, because this function is like inside this data type, if that makes sense. But in case that you have you are not using, for some reason you are not using pandas, that you could use, imagine that you are using a list, or you are using an NumPy, or you are using any other type of list, you can use matplotlib. And actually what we will, the sample that we will see now, we will come back to how to save this into different formats. The sample that we will see now is like extracting the data from the data frame, the pandas data frame, and saving it into a variables. That, for instance, we will use here two variables. We will use years, that is data.columns. And for GDP Australia, I will get data dot. I will get the column that is called Australia. Well, column or row depends on row. And here I will use a matplotlib. So we do a TLT plot. You remember I need to specify the x axis, that is years, y axis, that is GDP Australia, and also I can specify. Well, okay, let's do it. And this is also answering the question that is in the chat. Here, because I'm using Jupyter Lab, I don't need to specify plt.show. If I specify that, I get it's like a right. This line doesn't show. Actually, if you use a Python script, this plot will appear in a new window. But because we are using Jupyter Lab, this plot is like inside that notebook. So in this case, for instance, we can get rid of this line, but just to. And also, if you see, it's a red line. That, for instance, if we want to use a green dash line, we can specify that like this. The third argument, we can say G, that is from green, minus, and you get a green dash line. I think if we use B, should be blue. Yes. And I haven't tried just with the one dash line. Okay, it's like it's not a dash. Not sure if with 3. Okay, 3 doesn't like the. It's 2. Let me check if there are more. Yes. Okay, so now to save them. For instance, I'm happy with this with the colors. And okay, let's make it like a more. Let's make it well. Other title, for instance. Also with other x-axis. No, again, it's an x level. That's it. I'm happy with this. What I will do, I want to save this figure in my computer. So the way is plt dot save fig. And here I specify the name. For instance, if I want to use PNG, I can. What I only need to specify the extension, and automatically the library will save it as a PNG. So if I do Australia.png, you will see here that the file. Yes, you see now that I have a file that is called Australia. And if we open it, again, this is open in in Jupyter Lab. I mean, the good thing of Jupyter Lab is all of these tabs that you can play with. So you get this in PNG. What about if I want to save it? Because I say, okay, I want to save it in this format, and also I want to save it in EPS. This is to be useful for LaTeX. So in a few seconds, here in my left part of the screen, I guess that it will appear exactly Australia.eps. Not sure if I can open it. Well, okay, I can open it, but it doesn't recognize that. You can see that this is the format is EPS.
Yeah, encapsulated PostScript.
Yes, you have open with a text editor EPS file, but you see that is the save in that format. And also, if I think if we use help TLT.save fee, we can specify the resolution, because some papers said, okay, I want a resolution of 200 dpi form, exactly dpi. So you can specify it, quality, optimize, progress. So you have all of these options that you can specify on save fig. Let me check if there are more questions. Michael shared a useful link. Go here. You can see everything that we can do. We have a user plot, but we can use bar, scatter, stem, step, fill between. We can do all of these options. Also for statistics, is quite. We can use the violin plot, even plot, 2D, error bar, box plot, histogram, apply, XV. Can use this. So here in this website, for instance, you can find many plot types, samples, tutorials. So this is like let's say a complete, and we can spend several days going through all of these. And also here you can find the samples that you see that here also they use abbreviations like NumPy normally is they use MMP. Also you can select the style, and for instance here there are all of these. You can set the limit ticks. So there are many choices that you can do. And here there are like more and more all of this info. I see that there is another question. If it's possible to select the size of the PNG. Yes, it is possible. And actually we will find the okay, let's come back to here and see the okay, it's not here. There is a way, but it's okay. It's not. I think it's. think the way is playing with the DPI. There is a way we can have a look at it later, but I think there is a way. I'm not sure if playing with the DPI, but should be like should be an easier way. But yeah, we will actually, yeah, it's interesting because also some papers can say, okay, we want a specific DPI, but it could be an easier way. Okay, what else? Okay, in this previous example, I will copy and paste. We have I will remove this. So I plot Australia, but what if I want to plot another country? I want to plot New Zealand. So I can repeat and I can say GDP underscore New Zealand equal data dot location, and I specify that the row that I want is the one related to New Zealand. And when I do the plot, here, as you can see, I plot the Australia, but I can plot New Zealand. Here I need to change the, I use blue dash. I will use, for instance, red. Let's see if red works. Yes, so I can get is the same figure, but you print two you print the two lines, one related to Australia and the other one related to New Zealand. Well, you see here, because when we use when we use the pandas data frame, we get automatically a legend on the this part on top left of the graph, but we can do it. We can add it manually. So to create to add the legend, we can do TLT.legend, and we can specify the location. For location, we can say upper left, okay. The error here that is they said that I didn't add a label on plot. So here what I need to do is comma label equal Australia, because okay, it complains that I will print a legend, but a legend of what if I haven't given any information about what is plot. So I need to add labels to each plot, to each line. So it's a new. Let's see if that works now. Okay, so now I get the legend on top. I think there is also a way that is called best, and with best choose the best location, because here I can choose upper right, but maybe it's not the best location because it's like here there is a lot of space. Well, here is a lot of space as well. So one way, if you trust in the in the library, you can choose a location the best and automatically choose the location. We have seen this type of graph, but also we can use scatter in case that you want to find any type of correlation, or not sure if in this case is relevant, but anyway, we will use. So a way to use that, we have here the data for Australia, for New Zealand, so we will reuse these two variables. So what we will do is we will create a new graph that is called TLT.scatter, and I needed to give two lists. That the one will be GDP Australia and GDP New Zealand. I get this menu because I click on tab and I can choose. I click, I type. So when I execute this, I get the correlation with like Australia and New Zealand. So okay, here maybe, well, you see kind of linear, but you can do the same with other lists, and you may see maybe a better correlation. Okay, what else? Oh, this is another website that could be useful, that is in the documentation, that is this one. And also here you have like examples of what you can do. So you have the code, so you can create all of these. You have this is cheat sheets that could be useful. Oops, close. That here is explain, well, like a lot of commands that you can use. And here you have in this in the menu, you can choose like I think this is the violin plot, and it explains to you a violin chart, and so you can do, or for instance, you can do something like this. So the library is very powerful, has many choices to. Let me check the. Yeah, thanks. That's Michael. So yeah, this is the link. What I will do, let me. There are two exercises here. We'll paste again the link in case that you don't have it. Here. There are two exercises, the number 2 and number 3. One is about pandas, and the second exercise is to print the minimum GDP per capita over all the countries in Europe. So please, if you can do both exercises, and when you are done, please say so in the chat. I will give for this like 10 minutes. If you finish before, just let me know. And also, again, if you have any questions or you want to play around with the Matplotlib or do something else, yes, feel free. Okay, so there is a question in the chat saying, how can I select just one column? In the data frame, you need to use, okay, we can see that example here. We have, I guess if we have data here. So if I want to select 1957, for instance, I need to use data dot location, and with the square brackets, need to specify. Let's try if that works. 1957. It doesn't work because it doesn't exist. So I need to. Oops. There's something wrong here. Because I think I'm using a string and it's okay. You remember I use this is the way. I mean, if we load this data from scratch, we need to use strings. But because we have changed the index, and the index now is a integer rather than a string, I need to specify the row for the rows. I want all of them, so I specify that with column. And the second argument, that is the columns, I specify 1957. I can also specify a slice 1962. I guess that I will get, yeah, something like this. And for instance, for Australia, of course, because it's a string, I will need to specify with quotation marks. Okay, so I think we can solve the exercises. Let me copy them like comments here. Oops. Oh, well, what I can do, what we have learned before, I can change that to Markdown and use so I can write the exercise in Markdown and then solve it. So GDP per capita. Okay, well, first of all, I will load the data. I will use the data Europe equal pd.read CSV, and the name of the file is data Europe, and here the index will be country. Oops. Okay, so I have data Europe, and I want the GDP per capita for all countries in 1982. So it's data Europe dot location square brackets all countries. So use a column and I need to specify from 1982. So it was GDP per capita underscore 1982. In theory, should work. Oh, doesn't work because this doesn't exist. Okay, now it works. So this is for our count. Oh, well, no. In 1982, I rather from 1982. No. Okay, so in this year, I get that Albania have this, Austria, Belgium. Okay, so this is the solution. GDP per capita for Denmark for all years. So same, I will copy and paste. So specify Denmark and all years. So column. So I get that for 52 I got this, 57, etc. What else? After 1985. So here, in this case, I can say I can use the column. I got 87, 82, etc. and all countries. Last, GDP per capita of each country as a multiple. I will copy this. Remember, I can have it as a comment. And I think the solution, yeah, the idea was to divide the country. So it's data log each country, so it's all countries. GDP per cap. 2007. Let's see if that. Okay, so it worked, and now is the divided by the same, but it's 1952. So this is the answer that they ask. So now the comparison is saying Albania, for instance, is 3.7 times, Austria, etc. So we see that for all countries the GDP per capita is bigger. Some countries is 3, 7, 4. So you can have in one line this this comparison calculated. Okay, so second exercise was is here. Okay. Let me plot the minimum GDP per capita and the maximum. So let me see if that works. I will copy the solution in this one. What I do is divide the GDP per capita in 2007 divided by the GDP per capita in 1952. So again, for instance, for Albania, it's more than 3. I will copy this here. Doesn't show quite right, but okay, so it's the minimum and maximum. So let's see if that works. So it's a GDP, no, data, Europe, should be something like the minimum of the plot. If I do this, okay, this is the minimum, and they ask also the maximum, so I can do the maximum. And one thing that I do notice here on the bottom, that because rather than printing the numbers, I print everything. One thing that we can do is like these labels, I can rotate them 90 degrees. So how we can do that is TLT.xTix rotation equal 90. And you see that now, and we can maybe because we have rotated 90, we can play, we can see, okay, let's try if 30 is still, oh, so yeah, if we use 30, we can do something like this. Let's use pt.show to get rid of this output. So this is and then you can add a legend. If you add a legend, you need to remember to add a label here. Maximum. So this is could be one of the solutions. Also, regarding the question, I found there is a way to do that. That is the way of, okay, a previous question was to select, when we save this to a file, we can select the DPI, but also it's possible to select the size. So to select the size, we need to use something like that. We need to use a figure that will be available where we will save the plot that we have get. That the way is like a TLT dot get current figure. So I use that, and then I can use a figure dot set our because. And here I can use a figure dot set size. In this case, I need to specify inches, so I can specify 8, 6. Also, that is if I want to use centimeters, I could well, previously figure out the size and convert it to inches. So I can use that, and then I can use a TLT dot save fig, and I specify the exercise 3, for instance, dot png, and DPI I can specify 100. So if I execute that, I think that I will get exercise 3. oops, but I haven't saved anything. It's because it should be like in the same. Okay. Moment. See if it works better. Okay, so it doesn't work, my solution. So I need to check why it doesn't work. Okay, I'll check and I will let you know the solution later. Sorry about that. Okay, so this is regarding plotting. Do you have any other questions? I don't know why it doesn't work. Oh, maybe it's because of this. No, doesn't work. Okay, so fail.
Hello.
Hello. Yes, please.
Sorry, I have one question. That in this last, like the last task where you plot this minimum and maximum.
Yes.
And you use the data like slash Europe. I mean, I only want to know where you define this one first.
Yes. So thanks for the question. We have defined it before in the previous. Yeah. Sorry, that's not complete. I will copy here to make this more. So this will be the complete. I will remove this figure. I don't know. I'm doing something wrong here.
Okay.
So this will be the completer. Like I read from this CSV, I read the file, and then I plot the minimum, maximum, and then where I do the modifications that I want, and so.
Yeah. I mean, yes. Like I think I make little mistake that it's like the figure shows, but it didn't show these two curves. But I have to check the check this command again. Thanks.
Yeah, no problem. So is there any questions? If not, it's okay if we have Michael?
Yeah, there's a question in the chat. Well, as reports of a type error trying to run plot.legend. I'm not sure. It looks okay, the code, unless I can't see the minimum plot. So I assume the label for that is also okay.
Could be because okay, but it's weird that It doesn't complain about like in the line 3 complains in the line 4. Maybe it's because it's missing if you add like a location test. Oops. No, it's not location, it's
is it lock? Is it LOC?
lock. Yeah, lock test. If you add this, maybe it works. Okay. So maybe it's a PLT rewrite for some reason. To make it more complete, you can use import pandas as PD, import matplotlib plot.
Is there a matplotlib command, plot.clear or something like that that allows you just to restart?
Yeah, one of the things that and you can get rid of is like if you click here in kernel, you can restart the kernel. And you get rid of everything that we have done until now. I can do that. Restart kernel, let's see. Our variables will be lost. Start. And now if I execute the data Europe, to complain. Yeah, data Europe is not defined. And here if I execute everything, yeah. Close pandas, matplotlib. So this is also a way, in case that you see something weird, you can do a kernel and you can restart the kernel. I think there is a way, but I don't remember that is to get rid of all the variable that has been already defined. But yeah, another way is like to restart the kernel. Also, for instance, if you want, imagine that you want to save this and upload this somewhere else. You see that here we have all of these outputs. You can also restart kernel and clear all outputs. So let's try this. And you see that now the document is cleaner in that sense, that so you don't have the outputs on the. So you can do run all cells. No, this is here. Or render or markdown cells. So these are the options that you can have here that are quite interesting to learn. Mainly in run kernel. Also in edit, you can copy, cut, paste cells. Okay, so we are close to the afternoon break. We'll stop for 15 minutes. And in the last part of the course, what we will see more, we will see some structures like a for loop, conditionals, lists, etc. that might be useful for your Python scripts. Okay, so let's have the break now and see you at in 15 minutes. I'll type that in the chat. Stop sharing. Hello again, welcome back. So in this break, I managed to find the solution of why it didn't work. The problem that I had before was that it was saving a figure that was blank. So if I execute that, and I see exercise.png, I see that there is a blank figure. I mean, there is an error. The error is here. It's because when I do TLT.show, it's like, let's say, not sure exactly but they say that there's like a kind of a figure or a buffer where we save all the changes, gets clear. So the way is to get rid of the TLT.show, or save the figure before. So if we execute this, and now I open exercise3.png, I can see the figure. I was thinking about that, why, for instance, save figure has DPI, so has the resolution. Normally, the figure size is you get the size, or you let's say that you specify the size when you include the figure on your paper, on the website, and you can play with the resolution. If you see that you include the figure and the resolution is quite bad, you can increase the resolution. One of the things that you can find, for instance, here, you see that the names here are cropped. So because we have defined that size. In that case, maybe we need to define this size and see if that makes a difference. No. Yes, since that there is a mistake here. But yeah, my recommendation, okay, you can define a fixed size, but I would say that is not important, because where it's more important when you save the figure, specify the resolution, in case that when you include that in the paper, the quality is not good enough. So before moving on, do you have any other questions? If not, in this last part of the course, what I will explain is some Python information that you need to know, like for instance, structures like the for loops, conditionals, list, etc. And that when you create a script, you may find them useful to know. So I will start with the list. So following the sample that is in the documentation, we can have a list of pressures that could be, I will use floating point numbers, 0.5, 0.75, 3.2.3, 5.4, 1.1. We have something like this. And I can print the list. And I have a list of 5. And also I can use the function length of pressure. And I get, okay, that we have a list of 5. To get elements of the list, I use the square brackets and the index. For instance, if I want to get the first element, I use the index 0. Also, I can use slices, so you can get the first 3 elements, etc. It's like the same that as we have seen before with the strings. For instance, if there is an error in the first element, the 0.5, right one is 0.52. I can replace that brackets equal 0.52. If I print the list again, I can do print pressure, say before modification. Oops. And here list after modification. So you see that the first element, oops, okay, well, let's make things there. Something like that. So before the modification, this is the elements that I have, and after the modification, I have this. Also, well, this is to modify elements of the list. I can append elements, so I can say for instance, pressures append a new element that could be 3.3. And if I print the list, we see that we have a new element, and the length should be 6 rather than 5. Oops. Also, I can delete a position that, for instance, if I can delete 5.4, so I can delete that. 5.4 is the position 0, 1, 2, 3. So if I execute that, and then I print again the list, oops, we see that now we have 5 elements, and the fourth element, that is 5.4, is not on the list. What I can do also is I can, if I have another list that is called, for instance, new pressure, that the list could have 0.12, 0.77. I can merge these two lists. Okay, see that there is a question that the element 5.4 is the fourth element, but remember that the index that we use starts from 0. So it's 0, 1, 2, 3. That's the here you specify the index, not the it's a little bit tricky. Okay, so thanks for the question. So we have a new list, and what we can do is we can extend the list. So we have the list that is called pressure dot extend, and the argument is the new list that I have. So if I execute that, and now I print pressure, you see that I have the original list here. Well, and the 2 elements of the second list appended to the at the end of also we can create what happens if I do like rather than use rather than extend, I use append. Let's see. If I do this, and then I print the list, you see that I have the original list, and what I have appended, rather than adding the elements, what I have appended is like the list itself. One of the things, the features that Python has regarding lists is that in other languages, you need to create a list, and in the list should have the same type. All elements should have the same type, but here is not the case. I can create a new list, let's say new list, and the list could have a 2, 3.5, or apples. We create a list like this, and if you print list, you print you see that you have elements of different types. Also, you can have an empty list in case that for some reason you want to start the appending element. So you can do something like this: new list, and you get an empty list. So you can do a new list, append 1, new list append 2, 3, and when you do a print list, new list, sorry, you have 1, 2, 3. This could be useful, we will see later, when we have a for loop, and if that meets a condition, you add it to the list or not. For instance, you can create a list of even numbers. So when you compare, if this is an even number, add it to the list. If not, don't add it to the list. Okay, see that is a comment following the sample if you were trying to make some operations with that new list, an addition. That's a good the advantage of list is like, for instance, one thing that we can do to the list is we can add we can multiply the list. For instance, a new list, we can multiply it by 3. Oops, that repeats the no.
Will it work if you put square brackets in just with a colon in there? So if you just have open square bracket, colon, close square bracket after new list, what would it do?
Oh, okay, here.
No, same thing.
Yeah, so in this, well, that's the thing, that here, for instance, if you multiply a list, repeats the list 3 times, but there should be a way to yeah, that's the things of Python, that this is always a school day. So yeah, in this case, yeah, you're gonna do. I mean, the thing is of having a list with different elements in some cases could be useful, but in some cases could be a bit dangerous, because that's the thing that when here apples, you cannot. This is a string. You cannot do. This is what we have seen before. You have some operations that work with the strings, but maybe doesn't work with the integers and the other way around. So we need to be careful with that. I think, okay, this works if we use this with the. That's I think this operation works when we use data frames, but yeah, it seems that it doesn't work with lists. Okay, that's things that. And also, that's the thing. Don't be when you have like a question or when you have a doubt that okay, what happens if I do this rather than this? That's the good thing of Jupyter Lab, that you can type or you can, and this is the best way of learning. Like, okay, what if I do this? What if I do that? You write something and you see the behavior that you get. Okay, so what's next? Also, if we want to, if we do a new list, if we want to get the element name in the position 100, we get an index error. That is, a list index is out of range because we don't have a 100 element. But in this case, the index we should have a 101 in order it to work. Okay, so more things about this is regarding list, and what we will see now are the for loops. What is a for loop? Imagine here that we wanted to multiply elements of the list. I'm pretty sure that there is a way to do that, but imagine that we want to do it by hand. So a for loop is we have a list and we iterate to that list and we do the changes that we want to do. Or well, for instance, we can print the list. So imagine that, okay, we have a new list. Print the contents, 1, 2, 3. Imagine that we want to print the elements of the list. So I can print position 0, no, print list, new list 0, the position 1 and the position 2. So I can do this. And I print, or okay, I can do this because there are 3 elements. But imagine that I modify the list and for some reason I remove the last element. That will fail because doesn't exist the second position. Or what happens if rather than 3 elements I have 1,000? Should I write 1,000 times print a new list and element? It's not the right approach. So that's why one solution is to use a for loop. For loop, the structure is for. Here I have a variable that is a temporary one, that is a number, for instance, or you can choose I or whatever you want. In, and here I specify the list. In this case, it's a new list. Don't forget the colon here. And then when I press enter, you may notice that here there is an indentation. So everything that you write with the same indentation will be executing this for loop. So if I want to print element, I do print number, and if I execute the for loop, I get this result. Also, I can, what else I can do? I can imagine like doing this like by hand, new list, or what? No, this should be like Michael, please. Yeah, seeing that you
sometimes when you're iterating over a list, you don't just want the item in the list, you might want the index at which that item appears. And what you can do there is you can have for I for your index variable. So you have for I, comma, number in enumerate, open bracket, new list, close bracket. And that's just, I've often found that to be useful.
Oh, true. Thanks. So
I type that into a chat just so you know what I mean. So in the loop that you've got in
okay, to I know what you mean. Yeah, like
be like that, like what I've got. It should. I think it's enumerate, and
that's interesting too. Okay, yeah. So thanks. I will use this example. So for instance, just to demonstrate that we can have different lines here, I can modify new list and equal number equal and number. Well, let's see if that works. And also what I mentioned before about the you see that this print has a different indentation. So if I execute it, it will be executed once because this will be the for loop 3 times and then print and if I include this in with the same indentation, you see that it's executed each time. And okay, the sample that thanks Michael. So here, for instance, I can have for I number in enumerate a new list. Don't forget the column. And now you can print index I value and number. So you what you do is you have you have the index that is 0, 1, 2, and also you have the number, the value, the contents that is in new list that is 1, 2, 3. So yeah, this is also a good feature to learn. What else regarding for loops? In case that you forget the indentation and you write something like this, you will get this error that they will say indentation error, expected and indented the block. So here, if you do the, normally are 4, 1, 2, 3, 4, 4 spaces. Well, you can use different, I mean, they need an indentation to So you can do that. Also, there is a function that is called, you can use, if you want to generate a list, you can use the function range. Just this is the sample for number in range 0, 3, column, print, number. So here you, with the range, you generate a list that starts with a 0 and goes up to 3, but again without the, so it's a 0, 1, 2, and then is the 3 is the limit, so it's not including the. So this is regarding for loops. Let me. Okay, I was checking if I was forgetting anything. So this is regarding for loops. So now what we will see here are conditionals, because let's take the list that I have generated before. For instance, this one. We'll redefine pressure equal this one. And let's say that they want to print the values that are larger than 1, for instance. So what I can do is I can use a for loop for number in pressures. If number is greater than 1.0 or 1, again, don't forget the column here, print number. If I execute that, you see that the elements that are print are the elements that are greater than 1. Also, you can add for the elements that doesn't meet this condition, you can add else. Oops. Remember that the indentation should be, you can print something, or you can say element is not greater than 1. As you see, for each element, it says it's not greater than 1, it's not greater than 1. You have this. You can do this with the with the enumerate, will be like a more elegant. So you could say element I is not greater than element this is equal to. So you can play around with this. Okay, I see that you have an error. Could you copy in the chat the whole between instances of list and int? it seems like it's yeah, there is an error that was in the type in the chat. Okay, so it could be like yeah, something with the no problem. Okay, so issue solved. I don't remember. I think there was a way also that you can play it. If you remember before what we mentioned about the mask, if you do pressures equal, sorry, greater than 1. Let me check if I'm not. Okay, this is the thing that maybe you have. This is the same error that you got, the not supported between instances of a list of integer. Okay, because
you might be able to do a list comprehension here.
yeah, I don't know what something like this. Or the no, this doesn't. No, it's not. Yeah, is that okay? Yeah, this is what we need to use is like a pressure. The element is greater than 1. So you can use a mask equal is. I think you can do pressures. Oh no, I don't remember the. No, I'm trying to. I think I'm mixing all of these features, so you can use them with the data frames, but with a simple list, you cannot use them. You can use them when you use a list, a NumPy list, but what we are learning here are simple lists, and I'm trying to use something that is not polys. But well, in this case, we see that what we can do, what we can. That's the thing that these of the list that we are using here are simple ones. When we use data frames, we can use or the pandas data frames. We can use something like give me the elements that are greater than a certain value. We can use masks, but this doesn't work for a normal list. That this is what we have, what we see here. Okay, sorry for mixing things. Another thing that we can add here is the structure that is okay, understand. It's in the chat is copied, yeah, because you are exactly the last element of the list is a list, is not a number. So that why, yeah, sorry, that's why I redefined this list of pressures. No problem. Okay, so let's do it again. This, so we have so I could say if the number is greater than 2, its number is greater than 2. I leave. I could also say if number that's not a good example. Number is greater than 2. Print number is greater than. Okay, let's see if that works. No, I will change it. Okay, maybe with the numbers is not the right example. Because at the moment, you see at the moment that this is execute, this condition is execute, doesn't jump to this other condition. Yeah, this is not like the right example. So let me try to modify this. Greater than 2. This. Okay, this is better. Very well. I like just guessing the samples. So for the numbers, I could say if number is greater than 2, so I say that. But if it's if it's not greater than 2, but is greater than 1, you can say, for instance, 1.1 is between 1 and 2, and if not, you can say the element is not greater than 1. Okay, this is a silly example, but in other cases, you can do. This is the structure that exists that allows you to make other samples. You can compare, for instance, if you have, let's say, you have north, south, east, west, and you want to use, depending on what element is, you can, if let's say if number is equal by number, you can do this. If the number is equal this other number, you can do this. So there are many options that you can do with the comparing them. Okay, so this is regarding conditionals. And what we will see now is there is another library that we have seen the iterations using a for loop, but what we will see is we will iterate through the files of, for instance, of the further data. So we have these files. So what we will do is we will do a for loop. For each file, we will perform an operation. So for that, what we need to do is we need to we need to use the variable that is, sorry, variable, no, we will use a library that is called glob. So it's import glob, and what I can do is, okay, I will print, I can print here all the CSV files that are in data directory. So I can say all CSV files in data directory. And I can use glob.glob. And here what I use is a regular expression. So it's a data slash star.csv. So this star means everything. Everything that means or any, yeah, that ends in the .csv. So if I execute that, what you get is a list. You get a list that with the data minder all, GDP, Africa, Americas, Asia, Europe, Oceania. And having this list, you can iterate through the list, and you can do you can perform operations. So if you do for file name in this list, this created here, you can do a print, for instance, a print the name file name. Okay, here I have an error, a syntax error. So it's an invalid syntax. I have mentioned before, like, please place the column, please place the column, but I made a mistake and a column is not here. So if you add it, also you see here that you see that it's a syntax error, and you see here the arrow that is okay. Here is something wrong. That the wrong thing is that the column is missing. So if I execute that, I see that I see all of these files. And what else I can do? I can do a file name. I can use data equal pp dot read csv file name, and I can print the minimum, for instance, of data minimum. So if I execute that, I get for, well, okay, this contains all. I get the minimum. Okay, this is a little bit doesn't showing because I made a mistake that when I index call country. Okay, now it's better. For each, I can get for Africa, I get the minimum. For Americas, Asia, Europe, Oceania. So as you see, for each, you can iterate through these files, and you can create a plot, or you can do whatever you want, and you iterate. You get a list of files, and you iterate through all of them. Okay, I will explain that because it might be useful. Because you have seen that when I print here I print the whole path, but what I can do is I can just print this name. What I can do is I can here import path lib, that is a new library, and when I print here, I can do, for instance, p equal path lib path file name, or I can put the stem. What I have done, I import this library pathlib, and I use the function path, and I use a file name, and what I get is only the stem of this path. So if I execute this, you see that the file name, well, file name, is this. I can use stem. Also, we have a key suffix. This is the, if it's .csv or whatever. And also I have the other element is the parent of this. You have here, this is the parent, that is the folder data, the name of the file, and this is the extension. So you can, P has these three elements: parent, stem, and suffix. You may find it useful for in case that you want to do also to check, for instance, in this for loop. Okay, well, here we have a filter by CSV files, but imagine that you remove that. You can say if the suffix is CSV, I will do this. If it's another file, yeah, a picture of a PDF or whatever, I do this other thing. So this could be useful for the loop. Okay, so any questions so far? If not, continue. We're getting closer to the end. So there are two other things that I would like to see. One thing is how to create a function, and also is important the variable scope. Okay, so let's continue with the functions. So to create a function, the idea of the function is if we will execute the same a lot of times, we can create a function and use that function rather than repeating the code many times. Let's see an example of how to create a function. A function is we need to define it, and we use a def. And now we need to define the name of the function. That is, for instance, is like a print greeting. It's a function that doesn't have any arguments, so it's empty. And now, again, don't forget to type the column. And here in the function body, we can write or we can execute whatever we want. So what we will print is hello. So here we have our function defined. So what we can do is later we can use this function. So use the function is the same name as you have defined, and don't forget to use the square brackets. You can use other functions that is like and use for instance what we have learned with the if. Okay, what we can do is def we can define the function is positive, for instance, and the argument will be a number. So we can do if a number is greater or equal than 0, we can print the number is positive, else int the number is negative, for instance. Let's save that, and we can play with, well, we can use the function. We can say it's positive 12, it's positive minus 3, and we get the output. The number is positive or the number is negative. My advice, rather, because normally when you create a function here, you use you print something, but in case that you want to make the function more, let's say, more usable, because imagine that you don't want to print, you want to reuse the function, but you want to do, you have two lists and you want to add the negative numbers in one list and the positive numbers in one, for instance. You can use, rather than this function, okay, we'll copy and paste. I can redefine and say return true or return false. This is another type that we haven't seen, that this is a boolean, that is either true or false. So we can define this, and I can say is positive 12. So I get true. If let's say minus 12, I get false. And depending on what I get, I can do one thing or the other. Okay, here again, this is like a tiny or a toy example, but imagine that you want to compare if there is a prime number, or if the number meets a certain criteria, or if the number is contained on a list. You can use this to play around. Also, you can define a variable inside that body, because I think you cannot use capital. Yeah, true in capital doesn't exist. It's like is the first letter is capital, but the other ones are not. That's why you get this error. It's hard to get a name error that is not, yeah. So that's the. Also, you can define result. Rather than return, you can say result equal true, result equal false. And then you can do return result, something like that. Really should work. So this is to create a function. Function could return, you want can return some things. If not, you can avoid the return. Okay, so the last part is the variable scope. So you see that I have here a variable that is called result, that it could be true or false, and I return a result. If I print result, I will obtain anything or not? What do you think? If I execute print result. So the best way is to see if what I get name error. It said that name result is not defined, but okay, I define it in this function. So here is what we talk about the variable scope. Variable scope means that the scope of the variable. If I define a variable inside a function, the variable is not available outside. So result will not be available once that is only available inside the body of the function. So it's only available here. So at the moment that I'm outside the function, I cannot use that. So this is this variable is local. It's local to the function. There are other ways that my recommendation is use them if needed, but if you can avoid using them, avoid them. So I'm talking about the global variables, because here you see that I'm sending as an argument. You can have a number, but what I can do is I can get I can define number in as a global variable, and then I can use the function. And then let's put everything in the same. I can say if it's positive or not. That should be true. What is the problem with this? Okay, here I'm using you see that this variable has been defined previously, and when I define the function, I can use that variable because it's a global one, it's outside the function. Why I don't recommend that? Because imagine that I want to create a new, okay, I will save my function in a new Python file. So what I will do is I will copy and paste my function. This function will work if I saved it in a file without anything else. The function will not work. Why? Because it depends on number. It depends on the global variable that, for instance, is not defined in this file. So my advice is avoid using these variables. If possible, please avoid using global variables. So here, for instance, you can define a number as an argument. And this function is better. You can save it in a file and you can reuse it as many times as you want in this program, in other programs. You will never have a issue with this. Okay, so this is regarding the scope, and one last thing is regarding documentation, to document the function. Let me. So we have this function here, but I think if I do help is positive. Okay, you get a positive number, but you don't get more information. So the way of adding more documentation to that is like you use a single quotation mark like the 3 times after the function is defined. And you can say this function returns positive if the returns positive. Returns true if the number is positive. And you can say arguments number the calculated. So you can write something like this. You define the function, and then when you do help is positive, you see that you have some help here. Well, yeah, you have like a more info here. Also, another thing is like add information here and also add a comments. Okay, what we have talked about Python. Python is quite readable, so you see this code and you totally understand if the number is greater or equal than 0 is true, if not is false. So you don't, for instance, in this case, you don't need to add a comment. But in case that you do something else or you want to comment something, you can add the comment with a hash and say there is one like this function is a part of the Edinburgh package, or any note that you want to include in that. And okay, just to finish, also the implementation, you will find that they talk about styles. A style means that, for instance, here the indentation is for spaces. I use, for instance, all variable names are in small letters rather than capital letters. So all of these, like let's say, style format, there are some some guides that are already defined. So one famous one is this one, style guide for Python code. But okay, it could be quite quite long. But there are other, I think Google use another. You have also the Google Python style guide, and that is also a tool that I think is that tool that when you execute that tool in your code, tells you if the code has that style, or you can modify the code in order to make the code written in the same. This is useful when there are several developers editing the same code. You keep the code with the same structure, so that makes the code more elegant in case that someone else wants to edit it. More documentation. Let me paste here. So you have a Python 3 documentation. Also, the PyCon is the largest annual conference for Python community. And also you have documentation from Jupyter, Pandas, Stack Overflow, and also, you have a search engine, you have Google. In terms that you want, how can I create this, or how can I list this other thing? You can always use. Normally, the Python documentation is quite complete. If you can either use help in Jupyter, or have here a tutorial, numbers. Also, you can copy and paste and see. This is like a more complete, have different samples, like okay, how to calculate Fibonacci series, etc. Okay, so we are close to the end. That is 5 p.m. Do you have any questions that you would like to ask? I will stop sharing. Okay, if there are no questions, before finishing, I would like to share you this link, that this is the feedback form. Is it? No, this is not the way. Sorry. Copy. Moment. So if not today, tomorrow you will receive an email asking for feedback. Feedback for us is very important, because first help us to improve the course for future runs, and also is a way to justify, because as you know, this course is free for all of you, and it's a way to justify that we have a good number of attendees, and to keep receiving funding to run these courses. Otherwise, it's more tricky. There are several questions. The first one is the recording of the session will be available on the website, on the course website. That is this one. So in a couple of days, they will be available. Also, you will find it in the ARCHER2 YouTube channel, but the links to the videos will be available in that link that I just pasted. Proof of participation, yes. Again, in the email that you received from training, I guess that will be tomorrow morning. you need to reply to that email and ask for the proof of participation. You will get it. Also, in case that you have any other questions, please feel free to ask them. That yeah, we'll be happy to answer them. If there are no questions, okay, so it's time to close the session. I hope that was you found it useful, and please, yes, please be in touch, and hopefully see you in future courses. And yes, have a nice rest of the day. Bye for now. Thanks.